Aleksey, I'm Aleksey, backend developer, will tell us about life in backend and how he used plv8. Good afternoon, dear friends. Most of the reports are perspective on Postgres from DBL. I'm looking at it as a developer. That's why we do not have so many people in the room. My name is Aleksey Fadeev. I am the back-end developer. I develop at .NET. It is Microsoft, but open source has been out open source for quite some time. GraphQL is the query language invented in Facebook. Probably there were not enough languages for queries, so they invented one more. So on the left-hand side is the query, on the right-hand side is the answer. Query, this is the structure, this is similar to the structure of received data. Data may be different, any data, but if we use relational database, the objects, the post users in our case, correspond to database tables, and fields are database table columns. And this means relations via an external key. So again, the query is on the left, the answer is on the right. So it may operate the other way around. The user may have comments, and for the user, if we ask for comments, comments is an array, a list of comments. My company where I work, we do development. So we sell developers services, and developers float from project to project. Once I was on a project where .NET was used for backend and GraphQL. I hadn't worked with this before, but most of the guys on the team had. When I deep dived in it, they showed me this picture, when you can select 2 out of 3. And they told me that there were 2 options. You either develop fast, but queries to the database are poor or slow, or option number 2, queries are good, but development is heavy, slow, and you will break your head against it. So I asked why. If we have a look at this GraphQL query, you will see 2 characteristics. One is dynamic set of fields, so the user defines an arbitrary number of fields, references and links between the tables, and the hierarchical structure with any number of levels in this hierarchy. Let's have a look at our stack. .NET in our case, it looks like Java. It's a compilated language with static typization. That means that we cannot change types of objects, and we cannot change compile types, and number of fields in the types is static and is not changed. So with dynamic data, it is hard to apply those languages to it. So all your queries are returned in the form of flat tables. So the problem with hierarchy arises. So we basically don't hit any of those points. So on this stack, if we develop, it's very difficult. This project was related to hard beverages, and those beverages had different parameters scattered across tables. So the goal was to provide flexible interface to the user, to the client, to be able to select tables they like. Front-enders like GraphQL, back-enders do not, because those tools available for the database meant that you had to write 6 classes for each table. It wasn't very easy, but my goal was to develop not the main functionality, but the administration functionality. They're providing rights, varying users, and I said, maybe I will do ISTPI, and they said use GraphQL with sophisticated queries and configurated structure. They thought, well, it would be good to have consistency, but in the interest of time, do what you are told. So we have selected option number 3, GraphQL go away. This could be the end of the presentation. This is certainly a joke, because we haven't talked about GraphQL in Postgres yet. So classical relational databases, things are not very well with them. PostgreSQL is the object-related database management system, and we have extension plv8. Most of the examples are based on JavaScript. Interpreting language, graphic typization, so things are easy there. Nevertheless, they write code for each table in each example. plv8 is also JavaScript performed in the database. So I had an idea to develop a storage that would provide backend. Inside the storage, there will be GraphQL queries. It will receive data and return data. So it will address the query, put it through all the levels of hierarchy, then collect it in the object of JavaScript, which is JSONB in our case, and sends it back. Sounds easy, but in reality, it was quite easy also. I did the first prototype in a couple of hours. To implement this, I needed information about the columns in the table and relations between the tables via external key. Those system tables are not very quick. To make them faster, so I made such views. This is a fragment of this function. Not all of it. It wouldn't fit on this page, although it's not too long. In the end, I will give you the materials and you will be able to exercise with it. It provides the appropriate functionality. The input parameter is JSONB, so the query of that type. If anyone has seen GraphQL, he would say that GraphQL is not quite JSON. I will explain that further a little bit. Let's assume this is JSON. Under this assumption, this function, which was written very quickly, it implements the full-fledged GraphQL backend. So you can take any table with columns with any level of complexity, and they will work. Later, I had another idea to do the same in a different way. Write a query with aggregate functions. They have aggregate in JSON, so we could write a query and get data through one query. We could get appropriate data. This query was written by hand. I like this syntaxes. You could actually rewrite it in version 12. We have non-materialized CTE, and they are deployed into joins. There is another tool, GraphQL engine hierarchical. It operates similarly and generates queries, and you can use it, but it would be a cumbersome solution. I'll explain why offline if it isn't interesting. I'll explain why I don't like it. This query is written by hand, but the idea, the point is, inside the function, on plv8, we can parse the query and build the SQL query, so there is nothing difficult in it. And indeed, my function is like this, and the results are identical. Everything works fine, so we have two options of backend. GraphQL and reading of data. So this JSON is not quite a query. This is a similar structure. JSON on the left, GraphQL on the right. May look similar, but it's not quite the same. JSON came to us from JavaScript. However, requirements to the standard are more strict than those to the object inside the JavaScript. In the JavaScript, you can have key values. The key values may not necessarily be taken in parentheses. So this is not taken as an object without commas, without values. GraphQL may have filters, and they get brackets and round brackets, and it doesn't look similar any longer. So you need a parser for the QL query. Parsing is available in npm package. If anyone has worked with npm packages, this is a package to develop on JavaScript. They are used for development of front end. This package is a set of original tools, and it can reference other packages. This package references GraphQL, if I'm not mistaken. Then we have a dozen of originals. How can we get it into Postgres? There is a thing like Webpack. Developers on JavaScript on big projects, they have library files, original files. They may have dozens or hundreds of GS files, and it is impossible to include them in JSDML. So they pack it into the GS bag. It is not readable by humans. It has variables and constants. There are no spaces. So it is packed and sent on the HTML page as a package. How to make Postgres and NPM friends? This could be a separate story, but I didn't have time for that. So I will make a report on that next time. So a function for Postgres is here. It was compiled by Webpack, which did parsing for SQL query. I mentioned difficulties, development of backend. Let's take the second option, where we build a query with aggregate functions and get one SQL query on JSON. So first we need to make parsing of the input object. In JavaScript, it also needs to be parsed. There is a library that does this parsing. I think it is available for all popular languages. Here, GS doesn't provide any benefits. Secondly, because Postgres is a universal DBMS, it returns flat tables, so there is no need to represent them as objects, because we already have available data, we give it to the client, and we're happy. So this way can be implemented on back end, but we can also do it in the database on plv8. Each option has its benefits. In GraphQL, you may have record queries or mutations. So here we add user, and in brackets we offer arguments. These are the values of columns that we add in the table, and then we take the same data, we retrieve this data. So we recorded type ID type 5 in the database, and then we retrieved the user and the text value of this type. This can be done. The second option is to take variables and with an additional parameter deliver variables in the form of JSON. You can see it at the bottom of the screen. So queries for records, the aggregate option is not good for it. The first option is good, plv8 function, which performs it. I haven't implemented mutations, although it is not difficult. I'm sure I will be able to do it. So we have two options. One is this function moving in the object and collecting data, and the second option is query with aggregates. I decided to compare performance. Originally, I thought it would be much faster. If I took aggregates, I wouldn't take the first option, but measurements showed it was not quite the case. I first made some handmade measurements. Data was chaotic, so I thought I had to build graphs. I wrote a program which runs it 4 times. As in sport, it selects the worst and the best and takes in the middle ones and select the best out of the middle values. Let's see how we compared the productivity, the performance. Blue is plv8, brown is aggregates. And the query has 3 levels of inserts. So on small values up to 9,000 elements, PLV works faster. Then we get the opposite result. So we see linear growth with aggregates, and PLV is exponential or quadratic. Those functions, to ensure relations between tables, I use the following. So I get the objects of the previous level, and not to ask for all of them, I make this following query. If the number of elements is too big, this query will be inefficient, and it's better to use join. But to test it, I made 2 types of functions, 2 options, one with in and one with join, and I compared them. So at big quantities, join operates faster by 5%, so it's not much faster, not dozens of times faster. On smaller quantities, in is more effective. So around 8,000, join begins to win. So I made micro optimization, took this magic value of 6,500. So the overall picture remained the same, but this crossing point, when the PL8 becomes working better, it shifted to the right. It was 8,800 and it became 9,500. If you look at it, this brown line, it has a spike. This spike is interesting. First, the aggregate works better, and then there is a spike, and then PLV8 becomes much better, performing much better. I try to understand why it happened. If you look at the query, you'll see that the third level of hierarchy called style, if I get it right from the subject matter, this is categorization of beer related to extractivity of the original product. The style ID is not present in every object, so in a small selection, this style is not present. But when you get at least one object like this, so the performance falls down immediately. So when Postgres sees that there are only 2 levels of hierarchy, so the upper plan is without level 3 and the lower plan is with level 3. So Postgres can guess it and can perform optimization. This prompted me for doing more tests with different data. When there are a lot of links across the tables, there were 7 tables. So the query with aggregates had more joins and more expressions. So the picture is the same, pretty much the same. Again, we see that at lower selection, PVL8 is better. At higher quantities, the aggregate query is better. So the crossing point is even further, around 1400. So the brown line also presents spikes for the same reason. So there was no object, then it appears, then the plan gets more sophisticated. Another option is here we have different levels of hierarchy. We had 3 and now there are 6. So it operates slightly different, but at the same time the principle is the same. At smaller quantities it is the same, then the aggregate function represents a spike. Then we're now talking about 60,000 or more. So then again the aggregate function query gets better. So if we compare these two options, we will see that at different data, with different data, the picture is the same, but it is similar. It is not identical, but similar. With small quantities, PLV is better. At higher quantities, aggregate function is the same, is better. So GraphQL is used for the front end most of the times. So front end does not need tens of thousands of times. That's why plv8 is better for front end. So the aggregate function represents spikes, and in plv8 everything is smooth. So the speed goes down because of the overall amount of elements. And it doesn't care about the number of hierarchies. plv8 operates inside database management system. For aggregate functions, it can work on any backend. So the first option provides for reading and recording, the second one only for reading. So further plans, what can we do? Support of mutation, support of JSON-B fields. You may have JSON-B objects in the database. So it is important that you can also walk across JSON. If you want to have views rather than tables, or you may not have external keys, you may want to have this for the sake of performance. Instead of system tables, you can use your own tables, indicate the links manually, and it will still work. You will not need to change the function. You will have to change the name of the table only. So we're planning to have not just a set of functions, but an appropriate extension.
So it was installed, and the backend was received. The best thing is that it works for every database. You do not have to write something specifically. You can try doing that. So if you ask me what I will recommend will I ever recommend GraphQL always instead of this solution? No, it's not like that. There are some drawbacks. And the goal of this presentation is not to persuade everyone to use GraphQL. I just want to say that if you made this decision due to some reasons, probably my approach will help you save a lot of time for you not to write too much code. And in my opinion, when is GraphQL suitable? Well, the first one is the requirements of the customer or contractor. And as all the functions were developed, they had no sense in redoing it. But actually they said that if I came to them before, probably they would have used this option. And they would save a lot of time. My experience of development shows that we do not just need to provide the data from the database to front end, but we sometimes need to process the data somehow, to group the data. So, in this case, GraphQL is not really suitable. But still, there are some simple projects where you just need to represent the data as is in the database, and there are a lot of queries. In that case, this option is suitable. And we have another item here. For example, you lack some resources. You do not have back-end developers, but you have a lot of front-end developers. And in the perfect case, back-end is not necessary at all because this function fulfills back-end. So you will have very thin back-end that will speech the result to the customer. It won't do anything else. And as my colleague said, when do we need to use GraphQL? For example, when updates are too expensive, so you launched your back-end and you actually need to launch another issue. So you used GraphQL, and using it you can make queries to all kinds of tables, and you can also use it as a tool for debugging. For example, in your front end you use REST, but for debugging you use GraphQL endpoint as well. For example, on production they do not give you access to database even for reading the database, and sometimes for debugging you need to get the data. So using this endpoint you can make such a query. plv8. Yesterday, Ivan Ponchenko said that it does not exist for Postgres 12, but it's not a problem. We can assemble it easily. You know, I work with Windows more than with Linux, but I managed to assemble it because you should just download the archive, make and install it, but it actually downloads all the source items of Chromium, because V8 is Chromium, and it will take you about 6 GB of space and quite a lot of time. But the extension will be small, you can install it into Postgres. After that, you will be able to delete that, but the intermediary buffer needs to have 6 GB, and it takes quite a lot of time. So you can just switch on this installation and go to bed, and in the morning it will be assembled. And for Windows, there is actually a manual regarding the way it can be assembled. I actually tried using it for Windows and I didn't manage to do that, but probably you should just need to make more efforts to do it. And there are actually ready assembles for 9.6. This is my contact data. You can try it if you want, and you can even participate in the development. Here you can see the link for all these materials and to the function that you can use with your database. You can use this barcode as well. That's it. Thank you. Thanks a lot. We have several minutes for questions and answers, so if you have some questions, you can ask them. Thank you for your interesting presentation. The question is, have you experienced a problem when you need to compare some fields that are not strictly text fields? For example, you need to decrease the value in the column, like field, lowered, and value in brackets. You mean for change? Yes, that is select. So we can do search or like, or something is unequal to it. So the value of this field, I mean that it is not used directly. Well, in this case, the syntaxes on filter is not really convenient. So if you need flexible filtration in terms of field value, then I'm not really sure that GraphQL is a good option for you. But once again, you can see a filter here. So in this case, it would be easier to write it on SQL. And here we have to write this kind of code, and actually there is no single standard here. Every backend in GraphQL, well, here you should describe the filter, you introduce your specification, and you do it in this way. If you are able to describe it with JSON, then it's good. The more options you have, the more time your function will spend to process it. But if you manage to describe it and transfer it to SQL, then it's good. But if it is too complicated, I think that GraphQL is not a good solution for such products. If we have no further questions, we can thank our speaker. Thank you.